Welcome to the 45 Minutes on webinar, today on circularity assessment, enhancing efficiency in the circular economy. But I'm really delighted to welcome to this webinar our new circularity research manager, Dr. Gabriel Carmona Aparicio. Welcome, Gabriel.
Thank you very much, Chris, for that welcoming. And thank you, everybody, for being here today. So I'm going to cover some of the aspects of circularity assessment and how there's a one dimension of the circular economy, which is a metrics, and how to actually evaluate the progress of the circular economy. So let's start with this first slide, which is the climate policies that we have at the moment. And here in this slide, we can see the global drivers of global warming by source of emission. And basically, we can see how energy represents 73% of those gases. And if we think about the policies that have been pushed forward for dealing with this aspect, are basically centered in three elements. One is clean energy. So it could be about nuclear energy, renewables, or batteries to storage that energy. The second aspect normally is a switch from fossil fuels to bioequivalence and the use of hydrogen. And finally, we have the carbon capture utilization and storage. If we think about these three main policies, there is a limitation. So we have some targets to 2050 to achieve that 1.5 degree scenario. However, the reality of the moment is that renewable energy only represents 13% of the primary energy used worldwide. If we think about biofuel equivalents, for example, if we want to replace kerosene, which is used in aviation, with biokerosene, so we will have to triple the amount of crops that we have at the moment to extract carbon. So think about, at the moment, a person requires 100 kilograms of dry carbon to supply sustenance and nutrition. If we want just to produce biokerosene, we will have to generate 200 kilograms carbon per year per person. So we can see that it's not actually easy or feasible to achieve this transition. And finally, if we think about carbon capture and utilization and storage, the reality is even, let's say, sadder, because we don't have real projects going on this and on this side. So that's on one hand, the energy focus climate policies. On the other hand, we have how society has evolved in the last 120 years. So since 1900, the material stock levels have increased 23-fold, and this level will continue, and a greater numbers of flow will be required to use and maintain the stocks that society tends to accumulate. Because we are, let's say, a society based on capital. So if we want to increase that capital, we will require more assets and more flows, and to maintain and expand those stocks, we will, that would conduce to a higher natural degradation, but biodiversity loss and climate change. And the reality is that despite the fact that we have increased our stock levels, that doesn't translate automatically in better quality of life. So, for example, I have here that 1.6 billion people lack of adequate housing, or 200 million hours are required working to get water or to go to school. So talking about consumerism, it's one side of the story. The other side is how society is also accumulative. We are also hoarders. So in the industrial ecology community, which is where I have been working recently, we have several approaches, and we are interested in tracing biophysical resources from extraction, what we call primary stages, to services such as sustenance, shelter, mobility, thermal comfort, all type of comfort that we know in society, and how these services also contribute to certain material aspects of well-being. So we have different approaches that if we use it within the community, such as the resource service cascade, or the resource conversion chain, or the Herman-Daly and means spectrum. So all these type of approaches, what I want to highlight is how resources are transformed through these processes, and how they finally end up, one, used both for stock maintenance and expansion, or secondly, to operate those stocks. So, for example, when we talk about stock maintenance and expansion, we can think about mobility, and we have here the vehicles, such as where there are cars, buses, trains, or planes, and the operational resources are, for example, the fuel that we require so for them to run, or filters that we consume through the year. So basically, once the resources are extracted, they end up in these two categories, and the different combination between the operational resources and the stocks maintenance, so or the flows and the stocks, give us different levels of quality and quantity of services. Which what the question here is how circularity can allow us to keep those resources in the loop between the resource extraction and the services. So all these resources circulating continuously. Now, the thing is, the circular economy has had several definitions and approaches. So I want to share here with you one that came from the Ellen MacArthur Foundation and have been updated recently with the new 2030 vision, which is we can think the circular economy as a system solution framework that aims to eliminate and circulate non-biological materials and regenerate the biological ones, all by design. So on one hand, we have this different aspect here in that figure, which is a simplification of what we know to be the butterfly diagram of the circular economy. So basically, one aspect is how can we transform the economy by design, because in that phase we can reduce 70% of several environmental impacts, and we have to also take the approach of system thinking, or the system approach, because the solution, it won't be very simple. We need several actors interacting to actually achieve that circular economy. And probably you are aware of the different circular economy principles, such as eliminating waste and pollution, keeping products and materials in continued use, or regeneration of natural systems. And also the circular economy goals, which are increase the resource productivity, maintaining resources within those planetary boundaries that are now, let's say, well known, including climate change, biochemical flows, alterations, water use, etc. And finally, decoupling the economic growth from resource consumption and accumulation, which is how can we think in an economy just not only thinking on continuous growth, because we have a finite planet, and we need to decouple these two aspects. So at the same time, like, I mean, that it's very tempting to keep this idea of entire circular economy as practical, achievable in reality. You know, that circular economy where waste no longer exists, or the materials are continually in closed loops, and the products recycle indefinitely. But the reality is that based on the laws of thermodynamics, it's that this is impossible. So That's why we have to think of the circular economy more as a framework and as a journey, where we have to face also the reality, but that's also a way to motivate that, okay, how far can we go into the circular economy? What is the real target of that circular economy? And that's why I want to present you with this framework, which includes 5 components. And that's the framework that ASI it's at the moment thinking and adopting for the circular economy priority. So we have 5 components starting from the life cycle stage, where we have different actors. Those actors have different roles. So for example, the bauxite mining, we have different roles, for example, more into regeneration of that soils that have been degraded, versus primary aluminium production, where you have more focus on how can I achieve more circular economy while reducing my greenhouse gases. So it would depend, or we have at the end of life recycling actors. So it will depend on my stage. I will have specific priorities within the circular economy. The second aspect is, what is my role in driving changing in that circular economy? So we have 3 different: enabler, influencer, and adopter. I will talk a bit more later. Then we have several circular strategies, 10 that are presented here, which is a way to group them. The 4 elements are the business model, which we have how we can work value networks or more service-based approach, and how can we increase traceability and transparency, which within the business models and the data that I'm sharing within all those actors of the life cycle stages. And finally, what you don't measure, you cannot improve. It's the metrics. How can we actually assess that performance, not just only in terms of quantity, but also in terms of the quality of the strategies, and then we will have indicators of indices. So going into that driving change role, we have 3 roles here. The adopter, which is enhancing the internal environmental sustainability performance, which is how can I work internally in the different entities by promoting circular practices to reduce GHG emissions, optimize resource consumption, implementing those strategies that I just mentioned in waste management or even water recycling. So everything internally. My enabler role is how can empower customers and suppliers in that transition towards the circular economy. So I can talk here about providing circular economy solutions through technologies, my expertise and innovations, or provide guidance to my customers and support them into that transitions, or collaboration, a lot of collaboration to co-create new products or circular products. And finally, I have the role of the influencer, which is how I promote collaboration among stakeholders to foster circularity. It could be through active participation in leading industry forums, for example, or establishing partnership with academic institutions or other third parties, and engaging with global or regional governments to set targets into the circular economy. So I will have these 3 roles are different for the different life cycle stages, but most of them somehow I will have to incorporate into my DNA as a company. Now, in terms of the circular economy strategies, and based on different literature reviews, we have 10 circular economy strategies that we would like to promote. They can be grouped into 4 umbrella strategies. So the first one is sustainable by design, where we have refuse, such as, for example, avoiding single-use or disposable products, and the rethink, which is how can I redesign my products, for example, adopting a cradle-to-cradle approach or sharing initiatives, and reduce, which very common or well-known practices such as lightweighting, less material use, downsizing, or right-sizing. So the second category of strategies are those called product resource efficiency, which includes reuse through modularity or easy assembly, repair which also consider remanufacturing and refurbishment, repurposing, which normally it's linked to how can upcycle that product, which means at the end of life of that product, rather than decrease the quality of the material, how can I maintain it or in fact improve it? Then we have a third category, which is the service sufficiency through regeneration, which, for example, could include the restoration of degraded areas, like in bauxite mining, or carbon capture gardens, which is promoting green areas within my company, or the green areas that are surrounded in my companies, and redistribution, which is it could be achieved through the provision of convenient and safe public services, or provisioning systems, decent living standards, energy communities, collaborative consumption. And finally, I have end-of-life recovery strategies, which are mainly recycling, which could be achieved through the traditional recycling, or that could lead to downcycling or reducing the quality of the material, or cascading for bio materials. And finally, reclaiming. One way to do that is through urban mining. So instead of mining more elements from nature, what about going back to landfill or the stocks that I have at the moment in cities, and extract the material directly from them? So in terms of circularity metrics, we have basically what is the purpose of them. We have the idea is to provide relevant information for decision making, and understand how far is the transition from a linear to a circular economy. So 5 aspects to consider into those metrics. For example, what is the need for measuring? It could be for product design, for reporting to internal or external stakeholders, for favor or support procurement decisions, or for driving change, which is what we're trying to do here at ASI. The scope would depend with going from macro, for example, if I'm assessing only my products, to meso, which is I'm assessing the entity or the company, or even going to macro, which is assessing a region, a nation, or the global, the world. Then we have the typology of this metric, which go from parameters into going through variables, indicators, indices, and assessment. And finally, we have what to measure. It could be measured in terms of functions, which I invite more to measure in terms of services, or if I'm also assessing the impacts linked to those materials that I'm evaluating into my circular economy strategies, for example, embodied energy or embodied carbon. And the key aspect is if I have a reference scenario or a baseline, and how I want to compare versus a reference direction, or what I would call a circular economy scenario. And finally, there are several methods which include material flow analysis, life cycle assessment, or input-output models that can support those indicators and indices. Now, let's say one of the key metrics that are becoming more used by different stakeholders and industry in general are circularity indices, which are conceived to represent the circularity degree of a system, and normally are represented by a single number ranging from 0 to 1 and from 0 to 100%. Here I've included 6 of, let's say, common indices used by, as I say, stakeholders or industry. Despite the fact they are trying to be used widely, they are not still used massively by companies. So we have the Material Circularity Indicator, which is promoted by the Ellen MacArthur Foundation, which is mainly used for product design, and it has, let's say, high complexity or technicality. So sometimes it's difficult to communicate to other stakeholders. We have the Global Circularity Metric, which is promoted by Circular Economy, which they report, or they create the global circularity gap report. For example, here I'm showing their approach, which is for the total flows that goes out of the global system. For example, we had a circularity rate of 8.3% in 2019, and it decreased by to 7.2% by 2022. So that is a very common or simple way to measure circularity. As I say, it's only measured at the global level, and it doesn't differentiate between the different circularity strategies. And then we have other like circular economy value or circular economy index, which are monetary based. But as I mentioned, if we want to move away from economic growth into more service-based approaches, we also need to move beyond the monetary metrics. And then we have the cumulative service circularity, which is the CIRC-T, and it's how much service I'm providing through the whole life cycle of my product, and the eco-circularity performance index, which is one I'm going to present here. So taking into consideration that system, we have some inflows, some outflows, and in the middle, those stocks that provide the services. We have, let's say here, 4 checking points for my circularity levels. So if I want to reduce demand, so one way to monitor that demand reduction is through the material demand per capita and segregating this information per region and per segment. For example, if I'm into cans or I'm using it for buildings, etc. Then we have the slow stock degradation, and how can I measure the high quality service levels. I can use, for example, stock per capita, which can also be measured by region or by segment. And the eliminate waste. And this is, I put this admiration mark here because exclamation mark, because we are quite very focused into the recycling rates. And I want to highlight here is that for the circular economy to be a reality, we have to open up a bit more and not just only focus at the end of life stage, but we have to think from the demand side. How can I even change my demand of resources? But anyway, at the level 3, at the eliminate waste, I can have recycling rates. And for the cycle resources, I can have the circular rates achieved by each of those strategies that I presented before. So how can I actually achieve, if a product was designed for reuse, how much of this material we actually reuse rather than recycling or even repurposing? So how can we classify better the flows of materials and information? As an overall assessment of the whole system, I can also use the eco-circularity performance index, which will allow me to capture not only the quantity of flows, but also the quality of those resources. So going deeper into the indices, so this will be an index that will allow us to measure how far are we from full circularity. So it will go from 0 to 1. And I want to highlight here that full circularity, and as I mentioned, because of the physical laws restrictions, we will have to be coherent with those laws and define what are my practical limits and my theoretical limits. So, and theoretical limits meaning one in a perfect scenario when I will always have entropy and waste from my processes, what would be the maximum that I can achieve, and the practical limit, operational and human-wise, how can I actually achieve that circularity? So the circularity performance index is a combination of the circularity quantity, which is the alpha, and the circularity quality, which is the beta. And a way to represent here that index is through this matrix, which we have 2 axes, and where full circularity is 1 and 1, both of those axes. And depending on my level of circularity quantity and quality, combining them will give me the circularity index, which is in brackets. So for example, here, if I have a a system where it's a product or a company or a region with circularity quantity of 0.5 and circularity quality of 0.4, then I will have a circularity index of 0.2. And one key aspect of this index is that we will use a life cycle approach. We will be focusing more on a service approach too. We will combine not only the flows of material, but also the embodied impact of those materials, and also the impact of operating those materials. We can have some issues of burden shifting. For example, I can replace a material, but then at the production phase, I can improve the circularity, but then at the operational phase, now will require more resources. So that's why the beta requires a life cycle approach. Also, the alpha, we have to assess for the whole life cycle of products. So just to emphasize here, the alpha is the life cycle circular flows regard to the total life cycle material flows or even material stocks, depending the approach I'm using. And the beta is 1 minus the life cycle impact of my circular system, which is my reference direction, divided by the life cycle of my linear system, which is my reference point. And that system is one where I use only virgin materials. Everything goes into landfill or incineration. I'm going to show quickly one example of that, how this eco-circularity performance index can be used. For example, for mobility, I have here a comparison between the internal combustion engine vehicle and battery electric vehicle. So the alpha for the inflow, it's 0.22 for the conventional vehicle, which means 22% of those materials go into reuse, recycling, or energy recovery. A very similar value I have for battery electric vehicle of 0.24. Now, when the outflows, we have a high, what I just mentioned was the outflows, which is 91% goes into reuse, recycling, and energy recovery. And the 0.22 is only 22% of the materials that go into my new vehicle coming from circular materials, which is those ones coming from reuse or recycling. So we're quite good sorting the vehicle, but mostly into recycling, but we still haven't achieved a higher degree of circularity into the new vehicles that are produced. And now we have the same for the battery electric vehicle, very similar. When I use the beta for both of them, and now only measuring the CO2 impact of the whole life cycle of the vehicle, we have 0.06 for the conventional vehicle and 0.48 for the battery electric vehicle. And that is because the battery electric vehicle has a higher performance at the operational stage. So I can represent that index also in these radius. So the alpha and the in, which is the 0.22 for my inflows coming from circular cycles, and my 0.91 coming from going into circular uses. And now the beta for the material, which is how much life cycle is embodied, a carbon life cycle is embodied into those materials to produce it or to send it to end of life. And the beta for the operational, which is comparing a linear system, which is what we use at the moment, versus a circular system. So we can see how in this circular strategy of battery electric vehicle, the operational beta is high. And here is the matrix when we have the internal combustion engine of 0.01, the total circularity, and the battery electric vehicle 0.2. Quickly, how can this be improved? For example, using a lightweighting scenario where I'm replacing material for more advanced high-strength steel, or a higher share of aluminium, or a higher share of aluminium and carbon fiber. And that's one way of doing, which is replacing materials. And another one is using a Gruber scenario of the low energy and material demand scenario, which is how can I halve the demand of the global resources by increasing industry resource efficiency, and particularly for increasing vehicle efficiency by twofolds, or the stock efficiency increases by 40% through car sharing, carpooling, or better design of cities. What we have here is, for example, that for lightweighting, only using that strategy of replacing materials, the circularity index didn't increase much. In fact, it went backwards for some of the products. That is because just replacing materials as a solution for circular economy will increase the complexity of sorting those elements at the end of life. But when we go into a more comprehensive or holistic approach of dealing with circularity through a low energy and material demand scenario, we can actually see how going from 0.01, which is the conventional vehicle that we have in the moment, to 0.48, and which is much closer to that full circularity. And we can see here in this video how all the alpha and the beta parameters improve. So I want to just finish this presentation with some guiding questions to us when assessing the circular economy strategies, and that we hope to discuss into our circularity working group, which is what could be the theoretical benchmark for the circular economy. As I say, if we want to be coherent with the laws of thermodynamics, we have to actually say, okay, this is our further limit into this transition. So it has to be science-based more than just only a philosophical approach. What other scenarios and narratives, strategies could be proposed? I presented here the low energy and material demand scenario, but we can explore other scenarios into the circular economy. For example, particularly for the mobility case study that I presented here, what could be the results into other transport modes? What is the acceptance of such indicators by industry or other stakeholders, and to what extent reducing material demands, decreasing the resource criticality? So I hope to discuss this type of questions at this approach with some of you that will join the Circularity Working Group. I'm happy to answer any question at this stage.
Thanks very much, Gabriel. And we do have some questions that have come in using the question button, but also some in advance as well. So maybe we can explore some of those as well. I'll echo Gabriel's request for folks to come and join the Circularity Working Group. The more people we have along the aluminium value chain, the more valuable that work will be. There's a couple of questions from Winfried in the Q&A. I'm going to combine them into one, maybe. He asks, where in the circular economy strategies do we find resource and process efficiency in production processes? So not just the product through its life cycle, but in the processes themselves, which is kind of linked to the entity level for ASI's certification. His second question is about on the measuring for the product and for the resources. Is that only for individual resources, alumina, aluminium as inputs and outputs, or is it the other elements or other flows that are going on? So I guess, you know, carbon product flows, sodium hydroxide flows, these kind of things. And if there's a difference in weighting, which I think is linked to that first question, because it's about that product relationship, it's a process piece rather than the product itself. Maybe you can kind of address those two in one.
Yeah, absolutely. And thank you for that question. Very interesting indeed, because what I presented there, probably I didn't highlight it properly, was those strategies that are material and demand side focused. But definitely, as I showed at the beginning, we also have more strategies, like, for example, to implement in our entities to deal with reduction of greenhouse gas emissions, and also to increase the resource efficiency of my products, of my processes. So yes, definitely there will be room for strategies internally. Some of them definitely can be also applied internally. Like, for example, if I'm thinking about even reclaiming, if I have a, I don't know, a smelter that is going to be out of operation, what are going to be the end of life of that smelter? So, and how does what can I put processes to reclaim the materials coming from that smelter? But yeah, definitely in the day-to-day of my operations, I can think of more or additional strategies into the circular economy. Now, at the metrics, I can have also several approaches. I can go from the substance level, like if I do want to trace one element, or I can go into the product or a combination of all of them. So yes, there's room for mixing my material, because as I said, the more holistic my measurement or my metrics, the better, because if I just focus on one element, then I can create a environmental burden shifting. So I say, I'm improving the, I don't know, the aluminium circularity, but then probably that created an issue if I'm, I don't know, using carbon fiber or even steel. So I would have to, consider a holistic approach. Measuring at the substance level or the element level, it will give me particular strategies for that level, but I cannot lose sight of the whole system and materials.
I mean, that is a challenge, right? Is this kind of what is it, kind of iterative approach of this kind of going big to going small? And it's one that I kind of struggle with our entities too, right? Is that you can see there are a couple of entities where you can have a huge impact, probably just focusing on them. And then you've got a whole tail, but they have their own issues too, and they are not de-linked. So I think that lends itself to this idea that in the circularity working group, we're going to want folks from all the way along the value chain. It's not just those with large waste streams that are, dominating. It's those all the way along who have a role in achieving the circular economy. A question that came in actually in advance was, it makes some assumptions, right? It says that given that there's this demand globally for aluminium, how do we expect to achieve circularity, which they interpret as no more primary, which is an interpretation of that, right? But given there's this increasing demand for aluminium in order to benefit other parts of the system, the non-aluminium industry bit, how do we expect circularity to kind of improve over that time? You gave those scores earlier on. Can it be achieved given that demand is growing so much?
So I mean, particularly for aluminium, it's not necessarily about completely eliminating the need for primary sources, because at the moment, we have still low levels of service provision. So we will have somehow to balance, for example, the global north and the global south demands for these resources. So we still have some just to couple that service requirement versus resource demand. But at the same time, what the invitation about the circular economy is more not about just eliminating the primary sources, but how can we increase the efficient collection and repurposing of what we have put now into the socioeconomic system. Probably as IAI has raised or commented before, like 75% of the aluminum that have been produced still in use today. So how are we going to actually, want this product finished alive, put it back into the system and supply the demand? Probably thinking what is in use today. It's more also about that.
So I mean, that 75 still in productive use is kind of true of all metals. So,
true.
Because of this recent demand that's come along, it'd be quite interesting. I think we should explore this actually, is how much of that percentage is being consumed in areas that weren't the areas that produced it. So this is kind of, in this circularity discussion, I think it's important, the political aspect, that this is about maybe maintaining materials in a stock that is already servicing Europe and North America. It's not necessarily servicing the populations in the global south where the raw material potentially is coming from as well. So I think that's the important thing for the circularity working group to get a handle on. It's actually a bit of a question that came in advance, which I think neither you nor I have the answer to, Gabriel, although I'd encourage them to go and talk to International Aluminium Institute about this, is the regional outlook for scrap availability. Where is this scrap going to be available and with what quality in the world today? And that seems to be the rush at the moment, is where can I go to secure access to that material?
Yeah, definitely. As you said, there's still a knowledge gap there, and happy to bring that into discussion of the circularity working group, because we still have specific data by region and by segments about that scrap availability. And again, that is a result of the processes, technologies, and culture that we developed to efficiently collect and sort the aluminium. So that scrap, that the number is can be only modeled when we have actually put in place sorting systems, and we change our culture into the recycling and repurposing of the elements.
And maybe not generating that scrap in the first place. Which I think is going to be an interesting discussion for the future years, although probably not in the early years of the working group. With that, thank you very much, Gabriel, for presenting